My name is Mr. Hadi, and today we're going to be taking a short discussion, an interesting one, of course, on one of the topics in the elective mathematics. And our focus is going to be on how language helps us to develop mathematical concepts. This is an idea that was developed by a psychologist in Russia, and his idea, he believed that idea, he believed that before you can develop any concept, for example, mathematical concept, you will have to use a language. And language is a key tool that can be used to develop any concept when you want to learn anything or when you want to acquire anything. And that will be our focus with the use of this sequence or this particular topic. Now, before we introduce ourselves into this particular topic, I would like to take us to a short illustration. Now, I'm sure you do write exams, and when you are going to write exams, they put the chairs in linear form, isn't it? So, if you walk into a classroom and you realize that the chair that you're supposed to sit in an exam is arranged in a linear form, and these are arranged in regular intervals, such that the first chair is placed at 2 meters, and the second chair is placed at 4 meters. The third chair placed at 6 meters, and the fourth chair is placed at 8 meters. Now, from this linear arrangement, can you help me if I want to tell where I want to place the fifth chair, the interval at which I want to place the fifth chair from this particular arrangement? Can someone help me with that? Yes. 10 meters, that's very good. What of the sixth chair? If I want to identify the position of the sixth chair, yes. 12 meters. What of the seventh chair? 14. That's good. Let's clap and faster. So you got to realize that even though we don't have any mathematical knowledge yet, we don't even know the topic that we'll be learning, we're able to use our everyday reason to identify the answer to find the position of the fifth chair, the sixth, the seventh in that order. And this particular arrangement of numbers is what we call linear sequence or arithmetic progression. And that is what we are going to be discussing. So our topic for discussion is going to be linear sequence. Now, just like I said from the beginning, I said our focus is going to be on the idea stated by Vygotsky, and he said that the use of language to develop mathematical concept. And he also stated that to develop a concept, you have to start from somewhere and you have to end in somewhere. And usually, to develop a concept, you have to start from your everyday reasoning, and that is what we use to develop the answers to this illustration. Now we're going to translate this everyday reasoning into mathematical language. For example, if I could ask you, what would be the position of the 20th chair? To identify the position of the 20th chair, you're going to realize that you have to list the positions until you reach the 20th chair, isn't it? Yes. But that is very, very tedious. What if they ask you to find the position of the 100th chair? It becomes very, very difficult. And that is where we have to translate our spontaneous concept to formal mathematical concept. And to do that, that is where we introduce the formulas. That is where we introduce mathematical things. And that is what we're going to take a look at. Now, let's take a look at this set of numbers. If you have 3, you have 6, you have 9, you have 4. If I have to determine the fifth number, who can help us to determine the fifth number from this arrangement of numbers? Yes? 15. Good. And what would be our sixth number? Our sixth number? 18. 18. Good. Our seventh number would be 21. Good. Let's clap hands for ourselves. So when numbers are arranged in a linear form, such that to get successive numbers, you have to add a common number. This particular arrangement is what we call the linear sequence. Now, to translate this everyday reasoning to mathematical terms, we have to introduce a formula so that we can find any position of a number without necessarily listing them. And it comes with the formula Cn a bracket open n minus 1 multiplied by d, where Cn stands for nth term, A stands for first term, D stands for common difference. So now, from this formula, which is the formula for finding the nth term of a linear sequence, we're saying that Cn stands for nth term, A stands for first term, and D stands for common difference. So if you compare these particular mathematical terms to the illustration we have up here, what will be the first term of this illustration? What will be the first term? Yes, 3 will be the first term. So our A will be equal to what? 3, isn't it? Yes. And what will be the common difference of this particular linear sequence? What will be the common difference? Yes? 3. The common difference will be 3. That is very good. The common difference will be 3. Good. So now, since we are now using mathematical terms, if you are asked to find any term of any linear sequence, instead of using your everyday reasoning, you can now translate it into using what? The mathematical terms. And we're going to consider an example on how to use the mathematical language to solve the question instead of using the everyday reasoning. So let's consider an example. So given So let's take a look at this. That given 4, 8, 12, 16, and it continues. That we find the 10th term of the linear sequence. Of the linear sequence. So using the mathematical language instead of the everyday way, the first thing we have to do is, for the first step that we have to take, to be finding our value of A. That is the first step. So from this linear sequence, what will be our value of A? Yes, 4. It's going to be 4. That's good. So A will be 4. Then the second step, we have to find the common difference. That is D. So what will be our common difference in this particular linear sequence? Yes, that is 4. Good. Now we have to find our N. And they are asking us to find the 10th term. So what will be our value of n in this particular sequence? So since they are asking us to find the 10th term, our value of n will be what? 10. Good. So now to find the 10th term, what we have to do is we have to use the formula given to us. And the formula given is En, so the 10th term will be equal to A. And our value of A is what? 4. Bracket open. So we have n minus 1, right? And our value of n is 10 minus 1 multiplied by 4. Good. So our 10th term will be equal to 4 plus, we have 9 multiplied by 4. So 9 multiplied by 4 will give us what? So 9 multiplied by 4 will give us Come again. 9 multiplied by 4 to give us 36, right? So we have 36. So 36 plus 4 will give us 40, right? So our 10th term would be equal to 40. So what have you realized here? You're going to realize that instead of using your everyday reasoning, instead of using your everyday reasoning, instead of using your everyday reasoning, you use your mathematical language to now determine the answer. And that is the main idea that is developed by Vygotsky. So at the end of this topic, we realize that we've been able to use from spontaneous concept, we've been able to migrate to using mathematical language to answer mathematical questions. So any question? Okay.